Hello and welcome to Tech of the Day. Today we're going to talk about developing solutions that use Azure Cosmos DB. In my previous video, I talked about developing solutions that use Azure table storage, and I discussed a little bit about Cosmos DB there because we need to compare Azure table storage and Azure Cosmos DB. And now in this video, I'm going to talk about Azure Cosmos DB. So in this module, we will learn about Microsoft Azure Cosmos DB, managing containers and items, creating and updating documents by using code, server-side programming and features. So let's go. I have already discussed about the topics. So Azure Cosmos DB, managing containers and items, create and update documents by using code, server-side programming and features. First lesson. In this lesson, we will learn Azure Cosmos DB, core functionality, consistency levels, application programming interfaces, which means APIs, migration from NoSQL. Microsoft Azure Cosmos DB is a database service native to Azure that focuses on providing a high-performance database regardless of your selected API or data model. Azure Cosmos DB offers multiple APIs and models that can be used interchangeably for various application scenarios. Azure Cosmos DB is Microsoft's globally distributed multi-model database service for operational and analytics workloads. It offers multi-mastering feature by automatically scaling throughput, compute and storage. Azure Cosmos DB is globally distributed and it follows the data partitioning and best practices. So turnkey global distribution, elastic scale out of storage and throughput, guaranteed low latency at the 99th percentile, five well-defined consistency model, comprehensive service level agreements. So you see here it's 99th percentile. Azure Cosmos DB provides you SLAs with 99.99, so 4 nines. Core functionalities. Azure Cosmos DB has 4 core features that are same regardless of which API you use. First one is global replication. Second, varied consistency levels. Third, low latency. Fourth, elastic scale out. Let's talk about them. What are they? Global replication. It is globally replicated automatically. So automatic and synchronous multi-region replication, supports automatic and manual failover. Second is varied consistency levels. It offers 5 consistency models, provide control over performance consistency trade-offs backed by comprehensive SLAs. Then third is low latency. It serves less than 10 microseconds for read operations and less than 15 microseconds for write operations at the 99th percentile. So minimum is 99th percentile, which means you have almost 100 percentile. Elastic scale out. Elastically scale throughput from 10 to 100th of millions of requests per second across multiple regions. Support for requests per second for different workloads. So this is totally different than Azure table storage. Of course, it's expensive, but if you don't care about money and you care about performance, if you care about global replication, latency and scaling of your application, then you should go for Azure Cosmos DB. Let's talk about global replication. Azure Cosmos DB has feature referred to as turnkey global distribution that automatically replicates data to other Azure data center across the globe without the need to manually write code or build a replication infrastructure. So it's automatically distributed, globally distributed, and replicates the data to other data centers across the globe without need to manually write any code. Consistency level. Azure Cosmos DB provides 5 consistency levels: strong, bounded stateless, session, consistent prefix, and eventual. Bounded stateless, session, consistent prefix, and eventual are referred to as relaxed consistency models because they provide less consistency than strong, which is not the which is not the most highly consistent model available. Commercial distributed database fall into two categories: databases that do not offer well-defined provable consistency choices at all, and databases that offer too extreme programmability choices. Strong versus eventual consistency. The former burdens the replication developers with the minutiae of their replication protocols and expects them to make difficult trade-offs among consistency, availability, latency, and throughput. The latter pressure them to choose one of the two extremes. Further on consistency levels, the consistency levels range from very strong consistency, where reads are guaranteed to be visible across replicas before a write is fully committed across all replicas, to eventual consistency, where writes are readable immediately and replicas are eventually consistent with the primary. So, when you are writing to your Azure Cosmos DB, you want to be sure that it's consistent all over the replicated databases. But depending on your application, how do you want to do it? If you say strong, that means when a write operation is performed on your primary database, the write operation is replicated to the replica instances. The write operation is committed and visible on the primary only after it has been committed and confirmed by all the replicas. That means it does not show as written until it's written all over the replicated DBs. Whereas bounded stateless, this level is similar to a strong level, with the major difference that you can configure how state documents can be within replicas. State stateless refers to the quantity of time, the version count, a replica document can be behind a primary document. Then there is session, which this level guarantees all the read and write operations are consistent within a user session. Within the user session, all reads and writes are monotonic and guaranteed to be consistent across primary and replica instances. So they don't care about if someone else is logged into the database from other location with another session, then it might have different data than the current user who is modifying. Consistent prefix. This label has loose consistency but guarantees that when updates show up in replicas, they will show up in the correct order, that is, as prefix of other updates without any gaps. Eventual. This level has the loosest consistency and essential commits any return operation against the primary immediately. Replica transactions are asynchronously handled and will eventually over time be consistent with the primary. So your operations will be written and it will be eventually consistent all over the replicas. APIs. Today, Azure Cosmos DB can be accessed by using 5 different APIs. The underlying data structure in Azure Cosmos DB is a data model based on atom record sequence that enabled Azure Cosmos DB to support multiple data models. Because of the flexible nature of the atom record sequences, Azure Cosmos DB will be able to support many more models and APIs over the time. MongoDB API. MongoDB API in Azure Cosmos DB acts as a massively scalable MongoDB service powered by Azure Cosmos DB platform. It is compatible with existing MongoDB libraries, drivers, tools, and applications. Then there is Table API. The Table API is Azure Cosmos DB is a key value database service built to provide premium capabilities. For example, automatic indexing, guaranteed low latency, and global distribution to existing Azure table storage application without making any app changes. So this is same like Azure table storage, but with the benefit of automatic indexing, guaranteed low latency, and global distribution. Gremlin API is in Azure Cosmos DB is fully managed horizontal scalable graph database service that makes it easy to build and run applications that work with highly connected datasets supporting Open Graph APIs based on Apache Tinkerpop specification. So you have 5 different APIs that can access Cosmos DB. And fourth one is Cassandra. The Cassandra API in Azure Cosmos DB is a globally distributed Apache Cassandra service powered by Azure Cosmos DB platform, compatible with existing Apache Cassandra libraries, drivers, tools, and applications. Then there is SQL API. The SQL API in Azure Cosmos DB is a JavaScript and JavaScript JSON native API based on Azure Cosmos DB database engine. The SQL API also provides query capabilities rooted in the similar SQL query language. By using SQL, you can query for documents based on their identifiers or make deeper queries based on properties of the document, complex objects, or even the existence of specific properties. The SQL API supports the execution of JavaScript logic within the database in the form of stored procedures, triggers, and user-defined functions. So demo to create a Azure Cosmos DB account. In this one, we will create Azure Cosmos DB account using the portal, and then maybe I'll show you to create Azure Cosmos DB account using Azure CLI or PowerShell. Let's go to my portal, Azure portal, and here I will search. Let me just make it a bit bigger. And now I'm going to search for Cosmos DB, Azure Cosmos DB, and I'm going to create it. Now I need to fill up something, the properties. So I will say AZ-203 Cosmos group. So you see here you can have notebooks, but it's in preview, and preview does not come with SLA, so I have it off. With Azure Cosmos DB free tier, you will get 400 RUs and 5 GB of storage for free in an account. You can enable free tier on up to one account per subscription. Estimated $24 per month discount per account. So it's already applied. Location, I will say not US. Uh, okay. Okay, it's obviously non-production. Geo redundancy disable, but I want it to be enabled. Up to 33% of multi-regions rights is available to qualifying new accounts only. Offer limited to accounts with both accounts location and geo redundancy, and applies only to multi-region rights in those same regions. Both geo redundancy and multi-region rights must be enabled in account settings. Okay, let's go next. For the networking, I want it to be accessible via all networks. Okay, and then we can take care of security later on. But if you are not sure, then you can go for private networks, and then you can say allow access from my IP. This you can have more rules here. You can add more rules, or you can say public endpoints, and then also you can create rules, or you can say allow all networks. I'm not going to add any tag, but it's a good practice to add tags. I just don't want to. Validation failed. Information is missing or not valid. Okay, let's see what is missing in the basics. Oops, account name. So I forgot to enter the account name. Cosmos DB Hitesh should be available. Yes, and it is asking. Oh, I forgot many things actually. I forgot to talk about API, which we just discussed. Multimodal database service. So it is asking me which type of API I want to use, and as we talked about it, we have 5 types of APIs. I will go with core SQL. Let's go. This time it should be fine. Validation successful. Okay, create, and it is creating my Cosmos DB. It will take some time, I guess. Okay, the first thing it is doing is creating a database account. So to do the same thing using Azure CLI or Azure PowerShell, we can do it also using Cloud Shell. Here, I'll click here and have the PowerShell open. And I can select PowerShell, and I can create a storage and do the same thing here. But let's just first focus on what is going on with this. Deployment is in progress. As I said, I can do it with PowerShell, and also I can do using um, .NET SDK. It is also possible to do it using Node.js or Python or Xamarin. And okay, the deployment is complete. Let's go to the resource. As you see here, it's just taking me to the quick start, but first let's go to overview. So you see here my resource group subscription URI. It is accessible using for this Cosmos DB. This is documents, and if you try to access this, unauthorized message required header authorization is missing. Ensure a valid authorization token is passed. So you see here, I just copied this and just pasted it, but I did not provide the authorization header, which we will talk later on about it. And what else? So you have a data explorer, which you can use to explore the data, but you don't have any container, or so you don't have anything yet. Activity log, just create a database, so I don't have many activities here. Access control, I can provide role-based access control to my application, so I can add a role-based access control. Let's say I can say contributor or to one of my this, and select. So these are the available role users or applications I can add directly to it, but I don't want to add. Then yeah, settings, replicate data globally. So you have it here. It's really pretty straightforward and really easy. You can simply add a location to add or remove the regions to your account, and each region is playable based on throughput and storage for the account. So currently you have this region, France Central. You can add Switzerland North. You can add Norway East. You can add this one. You can add South Africa North, and you can. We are currently experiencing high demand in this region, so it's not available in India in any of the center, but you can say East Asia, Korea, and I added all these regions to automatically replicate globally, and I can save it. Oops, saved. Then the consistency, default consistency was session. I can say strong bounded stateless, which we talked about recently. So you see, it is just saying how much they are consistent. Still trying to replicate over other regions. Firewall and virtual networks, we said all networks already, so we don't have much firewall and virtual networks there. Private endpoint connections, I can add private connection endpoints with using which I can directly access my Cosmos DB. Course, which we discussed, simply You can allow a domain, you can add a domain to allow, and then you don't have, you will be automatically provided. Yes, so now you see the keys here, and using these keys you can access the Cosmos DB. If you add this connection string as same as you used to have um, in your .NET projects for SQL database as connection string, you just need to replace that with this connection string, and you can directly access your Cosmos database, Cosmos DB, because it comes with this account key and you can directly access it. You can add Azure cognitive searches to your index, to your Cosmos DB, which means you can have some some cognitive searches on your data. For that you don't have to do anything, you just have to switch it on, and then it will provide you some analytics over it. You can have a Azure function on it. Containers, we have browse, but we don't have any container yet, so we cannot browse it, but we can definitely add a collection, and in that you have to provide your name and like this, and you can simply add it. I am not going to add it because it costs money. Then you, if you have any container, you can scale it out, scale it up. We don't have any yet, so okay, and that's all. Same for monitoring purpose, you have metrics, alerts, diagnostic, and logs. Same way you can simply do the using the Azure PowerShell, and for that if I just have to create storage, and then I can simply use the commands, PowerShell commands, to create a Cosmos DB account. It is taking some time, but I just simply have to say new, that's AZ Cosmos DB account, then resource group name, location, name of the account, API type, which is like global document DB or what, enable automatic failover, default consistency level, max stateless interval in seconds, and max stateless prefix. Simple. I have to provide these things. It's just preparing the environment for me. Okay, it's ready. So I just have to type new slash AZ Cosmos DB, resource group name, and the name of the resource group I want to create. I have it already. AZ-203 Cosmos group, and then you need to say location, which is, for me, it's North Europe, or I can say West Europe or East Europe. Let's say West US. And there are two regions in West US, you can say West US 2. Then you need to say account name, so you say name, and the name of the account, I just want AZ-203 Cosmos DB. It has to be unique, so Nitesh 01, and then I need to provide API kind, default consistency level, max tailness, interval in seconds, max tailness prefix. I'm not going to do that because it is going to cost me money or also time. But this is pretty simple and for straightforward. You can do it as well. I'm going to just delete this resource because this will cost me money. Okay, by the time it is deleting, let's go back to our session. Consistency levels in Azure. 5 consistency models offered by Azure Cosmos DB are natively supported by Azure Cosmos DB SQL API. To achieve a successful migration, it is important to keep a few tips in mind. Instead of writing custom code, you should use native tools such as Cassandra Shell, Mongo Dump, and Mongo Export. Azure Cosmos DB containers should be allocated prior to the migration with the appropriate throughput levels set. Many of the tools will create containers for you with default settings that are not ideal. Prior to migrating, you should increase the container's throughput to at least 1000 request units RUs per second so that the import tools are not throttled. The throughput can be reverted back to the typical values after the import is complete. Next is migrating from NoSQL. Azure Cosmos DB has a MongoDB API and Cassandra API to provide a NoSQL service offering for two of the most popular NoSQL database platforms. Both APIs are protocol compatible, with Cassandra API supporting CQL v4 and MongoDB API supporting MongoDB v5. Many applications can be lifted and shifted to Azure Cosmos DB without the need to rewrite any code. So you can lift and shift your existing MongoDB or Cassandra. You can just lift and shift and you go to Azure. Managing containers and items. In this lesson, we will learn resource hierarchy, containers, and partitioning. Resource hierarchy. The JSON documents stored in the Azure Cosmos DB SQL API are managed through a well-defined hierarchy of database resources. The Azure Cosmos DB hierarchical resource model consists of sets of resources under a database account, each addressable via a logical and stable URI. A set of resources is referred to as feed. So a set of resources is called a feed. In this, we will talk about different terms used in resources. So you have a database account is associated with a set of databases and a fixed amount of large object. Blob storage for attachments. You can create one or more database accounts by using your Azure subscription. Database. A database is a logical container of documents, storage, partitioned across collections. It is also a user's container. Then collection or container is a container of JSON documents and associated JavaScript application logic. Collections can span one or more partitions or servers and can scale to handle practically unlimited volume of storage or throughput. Containers. In the Azure Cosmos DB SQL API, databases are essentially containers for collections. Collections are where you place individual documents. collection is intrinsically elastic. It automatically grows and shrinks as you add or remove documents. Each collection is assigned a throughput value, and that value dictates the maximum throughput for that collection and its corresponding documents. Alternatively, you can assign the throughput at the database level and share the throughput values among the collections in the database. If you have a set of documents that needs throughput beyond the limits of an individual collection, you can distribute the documents among multiple collections. Each collection has its own distinct throughput level. If a particular collection is seeing spikes in throughput, you can manage its throughput level in isolation by increasing or decreasing the value. This change to the throughput level of a particular collection will not cause side effects for the other collections. This allows you to adjust to meet performance needs of any workload in isolation. You can also scale workloads across collections. If you have a workload that needs to be partitioned, you can scale that workload by distributing its associated documents across multiple collections. The SQL API for Azure Cosmos DB includes a client-side partition resolver that allows you to manage transactions and point them in code to the correct partition based on partition key field. So, dynamically adjusting container throughput. So for this demo, we need to create a new container and specify a low throughput level, and then change the throughput level after container is created. So as in previous video, I created Cosmos DB where I said we need to create a container which we did not have at that moment, and in that container we can specify the throughput level. So it's simple. If you go to the portal, it's simple exercise just to change the throughput level. It is an option you can change after the container is created. So we're not going to do that. Partitioning. Azure Cosmos DB provides containers for storing data called collections. For documents, graph or tables, containers are logical resources and can span one or more physical partitions or servers. The number of partitions is determined by Azure Cosmos DB based on the storage size and throughput provisioned for a container or set of containers. If you are already familiar with this sharding pattern, the idea of dynamic partitioning is not very different. A physical partition is a fixed amount of reserved SSD solid state drive backend storage combined with a variable amount of compute resource CPU and memory. Each physical partition is replicated for high availability. A physical partition is internal concept of Azure Cosmos DB, and physical partitions are transient. Azure Cosmos DB will automatically scale the number of physical partition based on your workload. Partitioning implementation then. A logical partition is partition within a physical partition that stores all the data associated with a single partition key value. Partition ranges can be dynamically subdivided to seamlessly grow the database as application grows, while simultaneously maintaining high availability. When a container meets the partitioning pre-requirements, partitioning is completely transparent to your application. Azure Cosmos DB handles distributing the data across physical and logical partitions and routing query requests to the right partition. This third lesson will create and update documents by using code. In this one, we will learn about how to manage collection and documents. Manage collection and documents. To get started with Azure Cosmos DB API, you will need a Microsoft.azure.documents.db.core from the NUGET and reference the appropriate namespaces. So you need to install Microsoft.azure this package from NUGET, and then you can use these two namespaces, and then after that you can use document client class. You will see in the next example. First, you will need to add using directive for the namespace of your class, and then you can create document client instance by using the endpoint from Azure Cosmos DB account and one of your keys, which we just saw in the example we did for Cosmos DB account on Azure portal. I just showed you the endpoints and keys. To reference any resource in software development kit SDKs, you will need a URI. The URI factory class contains a series of static helper methods that can create URIs for common Azure Cosmos DB resources. In this example, we are creating a collection of URI by using database name and collection name. So first you create the document client using endpoints and key, and then you create a collection URI. In next example, you can also create URIs to access resources such as database or individual items or documents. Here we read a specific document and serialize it to a C# type by creating a URI for that document. So we create document URI and then use the document read a URI method with read document async and serialized type using this document URI. So it is serialized to this specific type. Then if you want to creating a document by using .NET, you have a document like this, and then you just call the client which we just had, create document async, and then we have the collection URI which we collected in the previous example here, collection URI, and we use this here, and the document we just have declared here an object, and just that we just created a document. To querying documents, then you can query by using SQL query spec. So here you query client.create document query for this object using the collection URI which we created and this type SQL query spec class, where you then declare query text equals to select star from F, where F dot surname equals to last name, parameters new SQL parameter collection with new SQL parameter last name, and that we could create this. It's the same we used to create for edu.net SQL reader parameters we used to send. So it's the same SQL parameter collection, and here we are simply creating SQL parameter, new SQL parameter, and passing the value. It's like you are sending the parameters value to the query. So it's the same, and then family is equals to query.toList. So you query it and then you just make the collection, and then the same query family with the collection URI where D equals to surname equals to D, select blah 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 as document query where var family equals to query.list. So you see querying documents by using .NET, querying documents by using .NET same way with different approach. Here you just using where and querying it like the link way, and here you are sending a query, SQL query using SQL parameter collection. Managing Azure Cosmos DB by using .NET. In this demo, we should use the Azure Cosmos DB SDK for .NET library to manage containers and items in Azure Cosmos DB. Then use the link feature of C# to construct Azure Cosmos DB queries. For this one, I will do a lab actually, because this requires a setup of proper SDK. Azure Cosmos DB SDK for .NET library, and I want to do it separately so that if someone is looking for a specific video only for C#.NET and Azure Cosmos DB, then they can find it. I don't want to mix everything and do everything in the same video, so I will do a lab, and as I said in my previous videos, I will do labs for those videos as well. So this is like a theoretical part, and that will be practical part. We will do it later. And yeah, then lesson 4 is JavaScript programming in Azure Cosmos DB and entity tags, e-tags. So JavaScript is a primary language for creating server-side logic for Azure Cosmos DB databases and can be used to write stored procedures, user-defined functions, and triggers, pre or post triggers. The next set of slides will use the example of each programmatic feature. Let's understand the stored procedures first. So in a stored procedure, in a typical database, a transaction can be defined as a sequence of operations that are performed as a single logic unit of work. Each transaction provides automaticity, consistency, isolation, and durability ACID guarantees. So automaticity, consistency, isolation, and durability ACID guarantees. So let's understand ACID in detail. Automaticity guarantee that all the work done inside a transaction is treated as single unit, where neither all of its command, either all of it is committed or none. So it's as a whole bundle is treated. So it's whole unit if either it's done or not. Consistency makes sure that data is always in a good internal state across transactions. Isolation guarantees that no two transactions interfere with each other. Generally, most commercial systems provide multiple isolation levels that can be used as per the application needs. This diagram illustrates the process of running a stored JavaScript procedure on Azure Cosmos DB server and common tasks that might run within the stored procedure's scoped transaction, such as creating, querying, updating, and deleting documents. This is how it looks like a JavaScript stored procedure. So this stored procedure takes an input parameter named document to create, and in this example the parameter's value is body of the document to be created in the current collection. All operations are asynchronous and depend on JavaScript function callback. The callback function has two parameters, one for the error object in the case the file fails, and one for created objects. And inside the callback, users can either handle the exception or throw an error in case a callback isn't provided, and there is an error. Azure Cosmos DB runtime throws an error. In the example on the slide, the callbacks throws an error if the operation fails. Otherwise, it sets the ID of the created documents as the body of the response to the client. Here, set body and document created.id. Bounded execution. All Azure Cosmos DB operations must complete within the server specified request timeout duration. If an operation doesn't complete within this time limit, a transaction is rolled back. And all function under the collection object for create, read, replace, and delete documents and attachments return a boolean value that represents whether the operation will fail, complete, or not. So let's understand transaction continuation. Functions can return any value. You will use this value to resume long-running functions after the server's specified time is over. For example, you might have a function to upload millions of documents. If the server's specified time is over before all documents upload, you can return a pointer to indicate how far your function progressed in the document upload. This will make it easier to resume processing in a new function iteration. So here in this diagram, you can see that it shows how the transaction continuation model can be used to repeat a server-side function until the function it finishes its entire processing workload. In this example, after the workflow begins, the return value is observed as each document is created. At some point, the document created method will return false instead of true, and at this point, pointer will immediately be returned to the client that originally invoked the function. The client will then resume the function by starting at the appropriate point in the list of documents to process. User-defined functions extend Azure Cosmos DB SQL APIs, query, language grammar, and implemented custom business logic. User-defined functions can only be called from inside query, then don't have access to the context object and are meant to be used as compute-only code. User-defined functions in SQL queries. User-defined functions are available to use in SQL query in a manner similar to built-in functions. In this example, we use the text function by fully qualifying it with the UDF namespace and passing in a numeric value. So UDF.text t.income is greater than 20,000. Optimistic concurrency. The ETAG value is generated on the server every time a document updates. If ETAG value says constant, it means that no other process has updated the document. However, if ETAG value unexpectedly mutates, it means that another concurrent process has updated the document. So here you say ETAG if match, check ETAG, then HTTP if it is changed, then HTTP 412 of error. Controlling concurrency in .NET. This code uses access condition class to take advantage of ETAG and avoid scenarios where document updates on server before the client finishes processing it. If there is an optimistic concurrency issue, the SDK will throw the document client exception and will return the appropriate HTTP status code, which is precondition failed. So if you see precondition failed status, then you say that another process has updated the record. So Here, that's how we can assure the concurrency. To this is so in this video, in this module, we learn about Azure Cosmos DB, managing containers and items, create and update documents by using code, and server-side programming and features. Of course, I will be doing another lab for Cosmos DB and operations for with the Cosmos DB using .NET SDK. But I prefer to do that in a separate video because that takes some time. I hope you liked my videos. So thank you for watching, and please like, share and subscribe. Thank you. Bye.